Good morning, madam. My name is Meghana. I am from Trimili. Today, my topic is analyze load angle stability of synchronous motor drives under sudden load changes. Introduction to synchronous motor stability. Synchronous motors are widely used in industrial applications due to their higher efficiency and reliable operation. Load angle stability is critical for maintaining constant motor operation under varying load conditions. Sudden load changes can cause transient phenomena that impact the stability of the motor's load angle. This is the diagram of synchronous motor stability. Here, speed reference and control and figuring three-phase and inverter synchronous motor encoder. Fundamentals of a load angle in synchronous motor. The load angle, also known as the power angle is the phase difference between the rotor's magnetic fields and the stator's rotating magnetic field. It determines the torque development by the motor and influences in a stability. Small load angles indicates stable operation, with large angles may lead to instability or losses of synchronism. Factors affecting load angles stability. The system the system's power supply characteristics and characteristics extensions level influence the load angle. Mechanical load variations and sudden disturbances can cause abrupt changes in the load angle. Parameters such as generator reactance and extensions control are vital for maintaining stability during load changes. Impact of sudden load changes is rapid load increases to tend to increases the load angle, risking instability if limits are exceeded. Sudden load decreases causes a decreases in the load angle, potentially leading to overcompensation or oscillations. These transient effects can induce oscillators behavior in the motor's rotor, affecting system stability. This is the synchronous motor structure. Here, three-phase input and yoke, stator, core stalls, and three-phase armature winding. And this is the base. Mathematically, modeling of load angle dynamics. The swing equation describes the relationship between torque, inertia, and load angle acceleration. Differential equation can model the transient response of the load angle during load disturbance. Analyzing these models helps predict stability, margins, and critical load changes threshold, stability, and criteria and conditions. The steady state stability conditions requires the load angle to remain within a certain limit, typically less than 90 degrees. Dynamic stability considers the system's response to transient disturbance and damping effects. Critical parameters such as system reactance and excitation voltage are essential for stability assignments. Methods for analyzing load angle stability. Small single stability analysis involves linearizing the system equation around an operating point. The transient stability analysis use numerical simulations to study the system's response to sudden load changes. Both methods helps in designing control strategies to enhance stability under load disturbance. Con- ah, Both methods help in designing controls strategies to enhance stability under load disturbances. Control strategies enhance stability. Extensions control systems can adjust field voltage to maintain the load angle within safe limits. Power system stabilizers help damp oscillations caused by sudden load changes. Proper systems design and load management are essential for improving overall load angle stability. Practical consideration and applications. Real world applications include power generation, motor drives, and industrial control. Engineers must consider system inertia, damping, and control mechanism to ensure stability. Continuous monitoring and protective systems and are vital to preventing stability and system failure. This we discussed about analyzed load and stability of synchronous motor drives under sudden load changes. Here we see the introduction and fundamental of load angle in synchronous motor, factors affecting load angle stability and impact of sudden changes. When the synchronous motor have impact of sudden load changes, then the rapid load increases tend to increase load angle, risking instability. If limits are exceeded, sudden load decreases causes a decrease in a load angle, potentially leading to compression of oscillations. This transient effect can induce oscillator behavior in motor's rotor, affecting system stability. Mathematically, modeling of load angle dynamics. The swing equation describes the relation between torque, inertia, and load angle oscillation. Differential equation can model the transient response of the load angle during load disturbance. Analyzing these models helps predict stability, margins, and critical load changes threshold. Stability criteria and condition. The steady state stability conditions requires the load angle and remaining with a certain limit, typically less than 90 degrees. Dynamic stability considers the system's response to transient distribution and damping effect. Critical parameters such as a system reactance and existence voltage are essential for stability assignments. Methods for analyzing load angle stability. Small single stability analysis involves in linearizing the system equations around an operating point. Transient stability analysis uses numerical simulations to study the system response response. Thank you, sir.